a rectangular sheet of paper. Fold the paper as it is shown. Cut off the remaining part of the paper. Observe that this part of the paper is a quadrilateral too. Let us name this as A, B, C, D. Observe that the four sides are equal in length and each of the angles is 90 degrees. Thus, this quadrilateral A, B, C, D is a square. Now join AC. Join BD. They are the two diagonals of the square. Let the diagonals intersect at O. Measure the lengths OA OB OC and OD. Here AO is equal to 11 centimeter. OB is equal to 11 centimeter. OC is equal to 11 centimeter. And OD is equal to 11 centimeters. We find that they are equal. Measure the angles. AOB BOC COD DOA we find that they are all equal and each angle measures 90 degrees. This is a square. Can you think why it is different from other quadrilaterals? Look at this hypothesis, which says that diagonals of a square are congruent and perpendicular bisectors of each other. Let us find out whether it's true or not. Let us consider a square ABCD. It has diagonals AC and BD intersecting at O. We need to prove that AC and BD are congruent and perpendicular bisectors of each other. This means that we have to prove 3 points. First, AC is equal to BD. Second, they make an angle of 90 degrees at the point of intersection. And third, that AO is equal to OC and BO is equal to OD. Now see, in triangles ADB and BCA, AD is equal to BC because the sides of a square are equal. Angles DAB and CBA are 90 degrees because each angle of a square is at 90 degrees. AB is common in both triangles. Therefore, the triangles ADB and BCA are congruent by side-angle-side rule. Therefore, AC is equal to BD because they are the corresponding sides of congruent triangles. As ABCD is a square, then it is also a parallelogram. Therefore, diagonals AC and BD will bisect each other at O. So, it is proved that AO is equal to OC and BO is equal to OD. Now consider triangles AOD and AOB. AD is equal to AB because the sides of a square are equal. Side AO is common. OB is equal to OD, which has already been proved. Therefore, triangles AOD and AOB are congruent by side rule. Therefore, angle AOD is equal to angle AOB, as they are corresponding angles of congruent triangles. Since BD is a straight line, sum of angles AOD and BOA is equal to 180 degree. Since the angles AOD and AOB are equal, twice the angle AOD is equal to 180 degree. Then angle AOD is equal to 90 degree. Therefore, AO is perpendicular to BD. That is, OC is also perpendicular to BD. Therefore, it is proved that AC is perpendicular to BD. Hence, we have proved that in the square ABCD, the diagonals AC and BD are congruent and also perpendicular bisectors of each other. The converse states that if the diagonals of a quadrilateral are congruent and perpendicular bisectors of each other, then it is a square. Here is a quadrilateral A, B, C, D. Its diagonals AC and BD intersect at O. But it is given that AC is equal to BD and they are perpendicular bisectors of each other. We need to prove that ABCD is a square. To prove this, first let us consider triangles AOD and COD. Here, both angles AOD and COD are at 90 degree because AC is perpendicular to BD. side OD is common in both the triangles. It is given that AO is equal to OC. Therefore, triangles AOD and COD are congruent by side-angle-side rule. Therefore, CD is equal to AD, as they are corresponding sides of the congruent triangles. Similarly, it can be proved that all the four sides of this quadrilateral ABCD are equal. Now, in the triangles ABD and BAC, AB is the common side in both the triangles. AD is equal to BC, which has been already proved before. It is given that BD is equal to AC. Therefore, triangles ABD and BAC are congruent by side-side-side rule. Therefore, angle DAB and angle CBA are equal because they are the corresponding angles of congruent triangles. Similarly, it can be proved that all the four angles of the quadrilateral ABCD are equal. As the sum of the angles of a quadrilateral is 360 degrees, each angle will be equal to 360 divided by 4, that is 90 degrees. Thus, each side and each angle of this quadrilateral ABCD are equal. Therefore, it is proved that ABCD is a square. ABCD is a parallelogram. ADEF and AGHB are two squares. Prove that FG is equal to AC. Now, work out the proof yourself.
Let us summarize what we've learned in this learning unit.